All right, great. Well, thank you everyone for coming online and in person. This event was kind of proposed to us at our last event, which do we have a little bit of an echo going on? I think we're good. Okay. Um, some of the feedback from our last event, which was Computation Design 101, was where can firms kind of reach out to have these computation ideas fabricated? And so we looked to Detroit to see who's doing digital fabrication. There aren't any kind of large companies doing mass digital fabrication, but that's still kind of rare even throughout the country. But we do have three kind of great companies that are doing digital fabrication in their kind of precise area and are leveraging it to create some pretty unique products. So Code D, we are Detroit's competition design community. We are part of AIA Detroit, and we empower students, professionals in the AEC industry to learn, share, implement computational thinking. And we do that through quarterly events, workshops, and different interactions. Our planning committee, John, who's not here right now, is our chair. We have myself, we have Nicola, Farella, and Francisco. They're all here. You guys can talk to them after the presentations if you want to learn more about about what we do, and if you're interested in helping us out, plan events and things like that. If you want to keep in touch with us and follow along with us, you can follow We Are Code D on Instagram, and then our YouTube channel, which has a lot of presentations. We also try to keep the conversation going on our Discord channel. If you want to join in there, we have channels to talk about competition ideas and then also support channels. So if you're developing some Grasshopper scripts and have trouble with that, you can post it in there and someone will help you out. And then, as I just mentioned, our YouTube channel, where you can go back and see some of our past events, and we separate them out into their presentations and the conversations. And we also have our tutorial series where if you want to learn Grasshopper sort of from the ground up, you can go through there we have 4 different volumes, and you can learn all sorts of different ideas through there. And so we have 2 sponsors for this event. We have Gensler Detroit and we have X Identity. And I want to welcome X Identity to share what they're about.
Thank you. Well, thank you, everyone. So we are X Identity. I've started with, okay. That's a photo. So we are located, what is X Identity? X Identity is a design and visualization studio with a brand department in it as well. We're focused in high-end visualizations when it comes to you guys hear me? Okay. So we focus in high-end visualizations when it comes to all the architectural projects, but also we have a department of branding and marketing as part of our structure within. What is X Identity? We started about 7 years ago here in Detroit with my partner Zach as well. We both come from the architectural industry, and we try and specialize within the visualization and brand field. X Identity came as a name where the X is the challenge, is the unknown. It's the client, it's the project in itself, and identity is what we bring in. So it comes in many forms and ways. It can come through graphics, but it can come also through visuals. We have 2 studios. We have one here in Detroit and one in Albania in Europe. And that's the team in Albania. Zach visited us there after 5 years. This is a list of our clients, almost every architecture studio in Detroit, except Gensler, I would say. And then we have eyes on you. And then on the right side is the team, some small projects at the bottom, but we're going to go more in depth. So we started opening the studio in 2016, so about 7 years ago, where me and Zach both went at Lawrence Tech, and then we opened our first studio in Ann Arbor. Then we decided to move back to Detroit. As I said, we have the visualization and brand department. And from there, this is our second studio in Albania where we grew. It's most recent open now. So a month ago, we just overgrew ourselves and we're slowly growing as well. Some of our well-known projects is F1 Miami that we're very invested on. And also the Hudson site here, it's an amazing project that we can work with in Detroit. And then some European project, the tower on the right, it's in Europe where it's located. It's a new development. A lot of community projects, but also at different fields and scales. We like to work with, yes, with big firms, but also small firms or friends of ours that have started a young firm. The idea is that we try and diversify within different fields. Let's say top left is more community-based, top right is more sports industry, and the two bottom ones are more retail. So each approach, I'm not going to go in detail, but each approach has its own feel of community or even rendering style, and it can go also with the larger scale projects like concerts, stadiums, and then we can narrow it down to even smaller projects like residential ones or even competitions. The middle bottom one is a shipping container competition in Nigeria, either Nigeria or Ghana, I think. And when I want to touch base a little bit about the branding as well. We have clients from retail, but also from fashion as well. Like we've been designing apparel, websites, apps, everything from a logo design all the way to a full package, branding package and guidelines. Restaurants, it came as a need for us to develop this department as we were designing spaces and the way that you'd promote the space. So we try to keep it within the department so that the architectural language or design can be carried into the marketing and the branding aspect of the space as well. I'll keep this short. So I was told I should keep it short. Right. Awesome. This is it. Any questions? No questions? Thank you. I appreciate it.
All right, thank you. All right, and so today we have 3 great presentations. We have first up our host, Citizens Robotics. They're going to talk about their 3D printing concrete. And I'm not going to do full introductions of everyone because we have so many people presenting. Followed by them, we will have Scott Shaw from Home presenting how they're trying to solve housing. And then we will have myself and Pandush for Make Lab and Cult Design Studio. So I'm going to give it to Fernando.
Hi, everybody. My name is Fernando Bales. I'm the Build Lab Manager here at Citizen Robotics. Thanks first to everybody for coming out. I see a lot of former students out here. Thanks to everybody online. Not sure who's all there. I just had some work done on my mouth on Saturday, so I'm on some heavy pain meds right now, and I'm gonna try to get through this as best I can. So Citizen Robotics, we are a nonprofit 501c.
Aspetta, amore, c'ho un...
What's happening? Cool. All right, so Citizen Robotics, we're a nonprofit 501c3. I like to throw this slide up because I think it exemplifies how we operate. We are always interested in collaborations. We've hosted a lot of folks through our facility here in Detroit. We've worked with young kids as young as 8 who have learned or have operated the robot. We've done workshops with students and various groups, including NOMA. Some of you are familiar with the Lawrence Tech Crit Prax, which we did last summer, as well as the Urban Land Institute here in Detroit. So what do we do? Well, Citizen Robotics is interested in working with robots to further automate the construction process. Robots can extrude walls. 1 second. Should be a video here, but doesn't like this laptop, maybe. It's all right.
If you might also need to stop sharing and then share again and make sure that you're clicking to optimize for video to make that stream well.
Thank you.
Mhm.
Stop sharing.
Because it hasn't even played yet.
There we go. There it went. All right. So what can robots do in the construction world? Robots can extrude walls. This is a gantry style printer on site, not ours, but we've seen many examples of houses being built in this fashion. Robots can also knit and weld reinforcements. We've seen a lot of examples of robotic rebar cage construction. Robots can also shotcrete over steel cages. We've seen plenty of examples of this happening out in the world. Robots can also spray foam. If anybody's ever tried to insulate their crawl space, this would be a godsend. Robots can smooth the surface. We've seen robots post 3D printing concrete come through and smooth out the surface. And we can also, robots can also mill a finished surface. We've seen robots applying texture, smoothing out, and drilling for different entities in a house. Robots can also paint. Again, if you've ever had to paint any type of wall, why not just have a robot do it? But robots can't do everything. So this is our first home here in Detroit. This is over on the east side, 1444 Sheridan. We are nearly done with this build, but what you see here is the exterior finish that we decided to apply stucco to it. This was not done with robots. This was still done with human labor. But today, I want to jump into a little bit of something that we don't generally get to talk about. Obviously, if you have further questions about our first house and how we went about it, we're happy to answer those. But I want to talk a little bit more about the design process and how we kind of fit into what today's discussion is about. So the first house, we started in a pretty typical fashion. We worked with Brian Cook of Develop Architecture. He's the architect of record. And he designed the house in a typical way, working in 2 dimensions, designing the floor plan, and giving us a layout. From there, though, we quickly realized that in order to 3D print anything, you need a 3D model, right? So if any of you have ever done 3D printing or are familiar with 3D printing, you need a 3D model. So while Brian was developing the drawing set, I was busy creating the 3D model that we were going to use to print. Right there, we immediately realized that there could be some efficiencies there. How could we use the same model that Brian was doing renderings with to 3D print? Unfortunately not. And this is where we started to rely on some parametric scripting. So in order to 3D print with concrete, we don't actually print the exterior surface of the model. We print the center line of the wall or the object that we want to print. This was a problem that had an easy solution. We worked with a former LTU student, Ryan Brooks. He developed a simple script that allowed us to take the perimeter line drawing that Brian came up with and quickly develop both the center line model or plan, as well as the interior dimension of that line work. That allowed us then to generate the center line model, which you see here, bottom left, that we use then to print. Here, bottom right, you see this corner wall segment. There's an outside line, a middle line, and an interior line. That represents both the bead width that we printed, as well as the center of that bead. This bottom left image is the surface that we used to print. Same as any 3D printing, we use the surface models to generate a print path. we put that through, or we put our surfaces through a slicing algorithm that we have to generate that print path. Here you see our digital twin of our robot that's right behind you there. That was the print path. And then pretty easily, we were able to export that to the robot. We work in Rhino robots, again, just a simple plugin to Rhinoceros that then generates the G code that works with the robot that we have. There you see myself working inside of one of the printed wall blocks. Again, I'm not going to dive too deep into why and the how of how we printed all the wall segments, but here on the right you see about I want to say 2/3 of all the walls for the first home. Another project that we relied heavily on parametric design was a small project we did for the 18th Street Design Build Green Hub here in Corktown, just a couple blocks away. They were in need of a new patio. They were having a lot of water and drainage issues in front of this small home. And so they approached us to come up with a solution. They saw that we could 3D print concrete, so why not try 3D printing some pavers? On the left, you see sort of the architect gave us some plans that we had to work with, but we were able to quickly use those plans to generate, again, working with another student, Carson Stickney, to generate a grasshopper script that allowed us to control the number, the size, and the permeability of each of those pavers. So taking the footprints of the patio, the script generates, again, the pattern of the pavers. And then depending on where we wanted more permeability, we were able to control the opening within each paver pretty seamlessly. And then on the right, you see us printing those pavers. And then a third project that I'll discuss or share with you guys is what we have in our break room. If you haven't had a chance to go in there, please do. This project was a close collaboration with Zachary Bellinger of Acoustical Ornament. Zach Bellinger is an acoustician. He's typically called into offices to retrofit spaces that are acoustically poor. We invited him in, showed him what we're able to do with the robot and printing concrete. And he immediately was like, wow, this is a great opportunity to finally design walls that are acoustically better than what we're used to. So originally we had, this grand vision that we were going to build ourselves a sort of standalone structure and maybe pitch it to Sonos to see if they could throw some money at it, and that never panned out. But we designed this shape that he was able to take into his software and sort of model the sound waves and how they performed within the shape that we had come up with. So on the left, you see one of those sort of the images that came from that study, comparing a rectangular space that is the same square footage versus a triangular one versus a triangular one that has concavity to the walls. And this surface, again, was generated parametrically. Again, we worked with Carson Stickney to come up with a script that allowed us to take just a generic surface or a blank surface and quickly apply texture to it. What we learned working with Zach is that both macro changes to the wall and micro effects to the wall help dramatically to disperse the sound waves that occur in that space. So obviously we weren't able to fund the full build, but we decided to print ourselves a small segment of that wall, which you see there on the right. And then that was installed in our break room just back there. And if you go in there, we strongly feel that you do sense a difference acoustically in the space versus if that was just, say, a generic block wall or drywalled on its own. And then lastly, I'll share just a couple of smaller projects that also were parametrically derived. The stairs that you see here in front were, again, a script that was generated. We type in rise and run and length and height, and it outputs the stair steps automatically. We also are always interested in any other type of textures or surface conditions that can improve a wall segment. The future of citizen robotics, we're always looking ahead in terms of where we'd like to be. Obviously, we'd love to have more robots and be more automated. Right now, we have just a single 6-axis robot that can 3D print concrete, but we do think that as this whole sort of field of 3D concrete construction progresses, that more sort of computational design and parametric software is going to come into play in terms of how much more efficient can we be from getting the design to the printer. We feel that there's a whole world there that is yet to be tapped into. So 3D scanning, Finch, if anybody's heard of them, a generative design platform for generating floor plans. And then bottom left, we see some prints from our close friend, Luai Kurdi out in the Middle East, and then robots doing more automated work in the residential world, such as spray foaming or spraying insulation. But there is a need for this, right? We're seeing that there is an incredible shortage in the residential home construction world, and we need more and more robots to help meet that demand. So with that, I thank you. Are there any questions now? Yeah. So I'm happy to answer any questions. I think we have the chat open as well. Yeah, go ahead.
There's two parts here, and you install them on site, and then you pick them up and you have to design them, pick them up.
Yeah, great question. Absolutely.
Can you please repeat the question for the virtual attendees?
The question was, do we print the parts here in-house, and then how do we pick them up, or how do we move them? And yes, all of that. We have to consider lift points and how we, how these parts get off of our print bed to their final location. So working closely with architects, engineers to design that into a print is critical. Yeah.
Would you be able to elaborate a bit more the citizen robotics as it's named? Because I know the name of your name means a lot. It does explain a lot where you are and what you do.
Yeah. So the question was, how does our name relate to what we're doing? So we think that 3D concrete printing is maybe just the gateway to further automation in the construction world. We're sort of agnostic in terms of what the robot is doing. Right now, it's 3D printing concrete, right? Or it's extruding concrete. But we think that the robot can do many other things, right? It can mill, it can cut, it can do whatever we want it to do. So the citizen part relates more to, because we're a nonprofit, we're not trying to protect any type of intellectual property, right? We really want to share as much of our knowledge with as many folks as possible, because we need this out in the world, right? We don't necessarily need it held in a private company, or, it's at the university level, which is great, but not everybody can go to university, right? And get access to this type of equipment. So our mission really is to share as much knowledge and get this out there. All right. Thank you, guys.